We have some amazing presenters from SAS and Weaviate today, and Daniel Katsari and Erica Cardenas. They have an amazing presentation about our partnership and what we've been doing together with generative AI. They've got some amazing content, and I'm super excited to see what they have to say. Without further ado, take it away, guys.
Thank you. All right. Okay. Hi, everyone. Thank you for joining us right after lunch. Can you guys hear me? This is quite unique with the headphones. That's amazing. Okay. So Daniel and I will be talking about unlocking enterprise knowledge with generative AI using SAS and Weaviate. Here's just a quick introduction about myself. Daniel, do you want to go first?
Sure. My name is Daniele Cazzari. I'm from Italy. I'm a senior manager in the IoT division, working on innovation and engineering. Erica?
I'm a technology partner manager at Weaviate. I work closely with our partners and integration collaborators to build end-to-end solutions and tell our go-to-market stories. So here's an overview of what we'll be covering in our session. First, I'll be providing an overview about Weaviate. Then I'll cover everything about search and generative AI. Then I'll tell you how you can build agentic AI applications. And then Daniel will cover introducing SAS, Project Ragu, and then a demo, which I'm really excited for you all to see. All right, so starting with the Weaviate overview. Weaviate was founded in 2019. It is a purpose-built vector database. We have over 1,000 plus customers, 20 million plus open source downloads. And I didn't say this before, but it is an open source vector database, so we do have flexible deployment options, and then we also have our managed solution as well. And we previously had won the GigaOM twice, part of the Forbes AI 50, and many other awards. In addition to supporting our various open source and enterprise customers, a few of them that I'd like to shout out are LTK, Morningstar, Instabase, FactSet. We support customers with all use cases and within different verticals that need vector search and just this new search kind of focus. So when you're considering building an AI native future, you need a platform that really supports, has end-to-end features that support your application. So we really do value our developer experience. We have a great community around Weaviate. We have scalable and cost-efficient architectures, and then again, we have the flexible deployment options as well. We've also seen the emergence in a new tech stack, and that's evolving with the AI native database at the core, like Weaviate, and then around it you have the data platforms, the frameworks, the model providers, compute infrastructure, and the cloud hyperscalers. This will probably make more sense as I explain what vector search is and generative AI, but we are seeing the tech stack evolve with these core components. All right, so now let's jump into the fun part. I'll cover keyword search. This is what is traditionally seen in traditional databases, and I'll cover that now. So with Daniele being from Italy, I love wine, huge wine connoisseur, and we were talking about rag or ragu. We thought it'd be very fitting to search for wines. So with keyword search, you have to know exactly what you're looking for. So I know that I need a red wine, it needs to be full-bodied, and it needs to pair very well with the red sauce pasta. So in my head, because I'm very knowledgeable about wine, I'm like, okay, I want a Barolo. And the traditional search engine will return the results because I specifically searched for Barolo and not an alternative. However, if I were to search for Rhine wine for ragu dish, nothing will pop up, and that is because in my database, it is stored by the type of wine and not the exact wine that pairs well with the pasta dish. But also, if you were to have a traditional search engine, one way that this could pop up and you can get Barolo returned is because you have a list of synonyms. So instead of ragu, you maybe have tomato sauce or meat sauce. This is kind of like the workaround, but again, it has to be an exact keyword match, so that's like the limitation to it. Now to vector search and why it is different and better. Okay, so if I search for wine for ragu dish, this Vietti 20, am I saying that right, Daniele? Vietti? Okay. Vietti 2021?
Oh yeah, Vietti 21 Barolo is a good wine. Yeah,
oh, nice. Okay, it's
exactly from my region, so great.
Awesome. And the reason why this wine was returned to me is because in my database, along with the name of the wine, the type of wine, I have a description about the wine, and it says that it is good with tomato meat dishes. And I hope we're all familiar with pasta, that's all we're talking about now, but ragu is a type of tomato meat dish. So the Vietti was returned because it understands that ragu is a tomato pasta. So how this is done. Vector embeddings are just an array of numbers that represent data objects. So you can convert any kind of data type into an embedding using the embedding models provided from OpenAI, Google, Cohere, any kind of, or hosted on Hugging Face Transformers, any embedding model, you can transform it into an embedding, and then it's stored in a vector index and then stored in Weaviate for efficient retrieval. So kind of an example of what this looks like. These embeddings are usually stored in a high dimensional space, but you and I, we can't actually see that, so this is just a simple 3D version. On the left, we have animals, and on the right, we have food. When a user makes a query for a kitten, the nearest neighbor cat will be returned because it understands that kitten is a cat. And it's also in the respective animal space and not near the animals because that's not what I'm searching for. So how this is actually done is vector databases use approximate nearest neighbor algorithms to efficiently store and index, or to index and then retrieve the vector embeddings. So in Weaviate, we are natively written in Go, and we have built HNSW, which is Hierarchical Navigable Small World, and it's a multi-layer architecture that is able to traverse down the graph to find the nearest neighbor to the query, which starts in the beginning, and then it traverses down to the pink. So the blue one is the query, and the pink one is the nearest neighbor. So it'd be like the blue dot is the kitten, and the pink dot is the cat. This is kind of what it looks like. Also in Weaviate, we support the flat index, and this is really good for simple use cases where you maybe have like 10,000 objects or maybe less than 100,000 objects, and you just want to do a brute force search. Sometimes you don't need to do an HNSW like a vector index search. You could just compare the object, you can just compare the query embedding to the objects in your database, and that's also very fast. But then one new feature that we've added is the dynamic index. So you can actually set up a threshold where you say if a user has over 100,000 objects in their database, switch it to an HNSW index, which is more, it requires more memory, which could be a downside, but it's also extremely fast and has less latency. So you can switch between these 3 different indexes in Weaviate. Excuse me, can we mute my microphone so I can cough? So the next one, I covered keyword search and vector search, but hybrid search is actually the one that fuses these 2 search techniques together. So you have vector search on the top. It said that context A, B, and C are the most relevant, but keyword search, which has the exact keyword matching, said that context B, C, and A are relevant. What this is then doing is sending it to the fusion algorithm so we can resort the results based off of the 2 search techniques. And we find that this is actually more efficient because sometimes if you have a query that requires the exact product ID, but you still want to have the semantic meaning, but you also want the keyword search, you want to have the fusion of these 2 algorithms, and this is how it's done in Weaviate. So when you are ingesting your data into Weaviate, we build the vector index to store the vector embeddings, but then we also build the inverted index, which is using BM25, so you can do the keyword match. And then in order to use it in Weaviate, all you have to use is an alpha parameter, so you make it extremely easy to use. An alpha of 0 is pure keyword, an alpha of 1 is pure vector search, and an alpha of 0.5 is weighting the 2 algorithms evenly. So that's just how easy it is to use hybrid search in Weaviate. So here's an overview of the 3 search methods that I covered. Keyword search relies exactly on exact matches. This is great for use cases where you need maybe like a specific product ID to be returned and you know exactly what you're looking for. But again, it's very limited because if you have a typo or you want it to understand the semantics of your query, it's not going to find it. Vector search is really good at understanding the semantics, but then again, if you have a query that you maybe want it to have the product ID, it might not be able to retrieve it because it might think that you are saying something else. But then here's hybrid search, and that is a perfect fusion of the two algorithms and is a popular choice that we see at Weaviate. So the 3 search methods that I covered, that's the first stage retriever. But now what you can do is add the second stage retriever for the re-ranker models, and this will actually give you a boost in relevance and accuracy. So with the re-ranker models, your query is passed to your vector database, whether you're using vector search, hybrid search, or keyword search, and it's going to output these initial set of documents. What is then sent to the re-ranker model is the documents along with the query, and then it's going to resort it based off of that. So as you can see, it actually turns out that the green document is more relevant than the blue document because it compared the query to the objects again and then resorted this. The downside, of course, could be the latency. But again, if the first stage retrieval, you're just saying, give me 10 objects and then resort it, it's pretty fast. So now that we covered the first part of search, which is very key to doing RAG, the R in RAG is retrieval. So that was the first part. Now we can move on to the generative side of it. So here's an example of what a vanilla RAG kind of pipeline looks like. You have your documents, you split it into chunks, then you embed it, and you store it in your vector database. When a user makes a query, it's going to be sent to the same embedding model for retrieval. Then what is sent to the language model is the prompt, so the query that the user is having, that the user had, along with the relevant context that is stored in your database. That's the augmentation part of it. Then it's sent to the language model to give you the generation, and there's your response. So in summary, there we go. So in summary, we have the retrieve, you augment it, and then you generate an answer. But as we're seeing this evolve, we see it has started off with vector search. You see the power in semantic search. Everyone was going crazy about RAG because we saw how powerful it is and being able to connect it to your database. But now with agentic AI, that's really where we're seeing the future and where we are giving these language models more autonomy and the option to kind of just perform on its own and give you a better output. So how these agents are defined is at the core you have the language model, but then you have the memory. So the short-term memory is what is in your context window, but you also have the long-term memory. So that can be your conversation history or what is stored in your vector database. Then you have the planning. So this is how can the language model reason about the user's query and then anticipate the steps that it will need to take to answer the given question. But now the fun part is you can give it access to a whole bunch of tools. So whether this be a vector search engine, like your Weaviate collection, maybe a calculator, web search, Gmail, Slack, you name it, you can define any tool and give access to it via function calling to these language models. So in summary, an agent is comprised of the language model, the memory, the planning, and then the tools. But one component that I want to specifically focus on is React. So it's giving the language model the ability to reason and then perform an action. So it's just, React is just an iterative loop of decision making and then doing action-based activities until it has satisfied the user's query. So the language model gets the query, it reasons about it, it performs an action, sees if it's in the right environment, sees if it maybe needs to reassess the steps that it has already taken. It observes, and then it just goes through that loop until it has enough information to answer the user's question. So in summary, it has the thought, it makes an action, it observes its current state, and then it loops until it is satisfied. So I know I've been talking a lot, so I thought why not just throw in a quick example of how vanilla RAG would fail and agentic RAG would succeed. So back to our wine example, I have this query, what's the best Barolo under $50 to pair with the ragu pasta? And can you tell me where to buy it near me? If you were to send this to a vector search engine to do the semantic search, it might find the Barolo in my database, but it has no idea where I live because it doesn't know my geolocation. And it also will not add the $50 because that's a metadata filter. I could do a vector search with the metadata filter, but that would have to be two separate inferences or steps, or just combined into one. But if my whole query is just sent to the vector search engine, it will fail. So this is where vanilla RAG, that pipeline that I showed previously, will fail. But now, with agentic RAG and giving the language models the ability to reason and perform various actions, it's actually capable to do that because it not only searched for Barolos, but it also added the filter for wines that are under $50 to my vector database. It found my location using the geolocation API, and then it took all that information and then did a web search. So it did all the 3 steps just based off of my one query. And this is using agentic RAG. Okay, so again, here's just like an overview of what it would look like. So here we have the query again. You have the agent this time, and it's going to retrieve. So sorry if you could hear that. It could retrieve information from my Weaviate collection. Maybe it can also search through another collection. So something that we've seen in Weaviate with our query agent is that agents are capable of not only querying one collection, but multiple collections at the same time. And being able to do this in parallel is extremely efficient, and then also makes it more accurate because it's just accessing more data. It can access the calculator, the web search, etc. And then it's sent to the last language model to summarize the gathered responses, or gathered sources, and then gives the response. So in summary, again, you have the retrieval agent that accesses the external tools, and then the language model to summarize and finalize everything. Okay, so I know I've been talking a lot. I covered everything about search, generative AI, agentic RAG, and now I want to discuss like RAG in production and what this would kind of look like for different verticals. While I have like 4 listed on here, this can obviously be applied to anything that you can imagine. You know, language models are extremely popular. Popular, yes. Meant to say powerful as well. So you can kind of apply it to a variety of different use cases. So in the first one, we have with manufacturing, and we also have an awesome demo going on at the Streamline AI, Streaming AI booth, and it is a manufacturing data set, which I'll be very excited to show you. But also with code assistance, we've seen that gain extreme popularity with just being able to help developers with code editing and just being able to expedite their developing process. Then with travel, I know we all flew here or got a hotel or something. We all traveled here to this awesome conference this week. So being able to implement agents into the travel landscape is extremely interesting, and Booking.com has done an awesome job doing that. They actually just released their AI agent travel little chatbot thing, and it's actually pretty cool with what it can do. And then in finance, you can, of course, generate financial documents and summaries and really guide analysts to make better, more educated decisions. And that's actually what we'll be showing you today. So I'll hand it over to Daniel.
Yeah, thank you very much. Thank you, Erica. Yes, now, thanks to the collaboration we did with Weaviate, and thanks also to Erica to explain what is RAG, because usually it took me a while, I could introduce you a new tool we are working currently in SAS, and I will tell you when we are going to release at the end of this meeting, so you could stay tuned for this. I mean, this is a project around RAG. The code name is Ragu. This is why also we use the Ragu as the part. As you know, I'm Italian. All the stereotype of Italian is true. I love pasta. I like it. And I love pasta with Ragu. And I also love Barolo. So yeah, everything was correct from the Weaviate. We get all the right information. So, I mean, it's really the idea of this project is to simplify. So you understand over there that RAG is powerful, but maybe also complex, and also to put in place to establish in your enterprise, and also secure it. It's not an easy task. So what we're trying to with Project RAG, also codename Ragu, is to simplify this, enable you to choose the embedding you prefer and test among different embeddings. Also enable you to use the file in the format you like. You have a PDF, you need to do OCR, you need to extract table. All these things will be made easy with this application. And also, a very important point is that the application could be deployed where you need. It could be deployed on-premise. This is also a very good feature because also Weaviate could deploy on-premise with us. And it's quite a unique feature for a database, a pure vector database. And we could also deploy on cloud or whatever preferred cloud you have. So it's very flexible and it's very secure. We secure the data. We ensure that only the person has right to access to your data. So we are able to secure, and we'll see the concept of collection when you do the demo, but each collection could have its own security group. Having said that, let me show very briefly some of the feature, the most important feature in the flow when we generate a RAG. So the first important point is ingest data. We support several types of ingestion, some out of the box in the UI, some of them in the API, and also we offer you to write your own custom adapter in Python, so it's super flexible. We have several ways in which to support the transform of your document. So your document might have image inside or might be scanned. And this is all supported by the transformation. So we are supporting OCR directly in the document, and also we are taking your tables as they are, and we conserve the information on the table, enabling LLM to query the tables. And then we chunk it, so we create small pieces based on the semantic importance in order to make easy for searching. Then we generate the embeddings. So this will leverage some capability, unique capability of our product we use for implementing this is SAS event stream processing that enable you to accelerate Onyx models. So in this case, we have this acceleration that works on CPU, so we support OpenVINO, and we also support NVIDIA. So in whatever hardware infrastructure you have, we are able to run this. And we know that OpenVINO supports the vast majority of use cases that you might have. Only very high throughput use cases might be fulfilled by GPU. Then a unique source, so just to stay in theme with the Ragu, we also have the possibility to compress your data and quantize them. This is if you have a lot of data, you want to save space, save storage on your database. This allows you to do so with a minimum compromise on performance. And finally, of course, we populate our Weaviate database with all the information. And having said that, we show you what we are able to do in RAG, but we know that RAG is not enough for all use cases. We understand that, also thanks to Erica's presentation, that some use cases are more complex. Some use cases require interaction with tools, require complex workflow. And for this scenario, we introduce Ragu agents. So some specific way to encode your agent with the support of RAG. So our Ragu agent, could be developed as of now in Python, but we will support also in the future intelligent decision integration, as we see on stage, and enable to execute your custom logic, take advantage of all the beauty of SAS, because we also support the SAS Python package you saw in Workbench in the first presentation of day one. We allow you to do LM critique, as we say, understand with a model if you could critique the other model, and you could also invoke external API. That is also very important because internal API and external tool. And we'll soon support also the most important protocol in this area that allow to call tools like MCP or A2A. That's an emerging protocol that we are currently see as very proficient in the agent space. Then lastly but not least, we provide our source, so our access to our function, our RAG function in a secure way. So only if the user calls the agent as the permission on the data, it will be able to successfully run the query. So security is also always at the first point in our development cycle. And as I'll say also, we host them in an isolated container environment to avoid any compromise with the rest of the function. And everything is super easy accessible via the same API for a chat. So as you chat, you could use an agent in a very seamless way in our UI. And then let me introduce our demo, then I'll do something, show you some cool stuff we develop. So currently, we are in financial troubles. This day is not very easy. to understand how the share goes. There is token up and down. I mean, it's a problem. So I think that I want to try to save investments. I'm a bit risk averse. So I decided to, what if I create an agent that each day is able to crawl the internet and search for the most important information. I'm interested mostly in technology, so I focus the search on technology. Maybe somebody else who's interested in other field of investment, but let's focus on technology. So what I did is I'm creating a connector able to search the data on the internet, store them. So I have it, and I could reuse over day. I could compare between days what happened on the market. And I also decide to store the 10K information of the major company of my interest. They keep updating over time when they change or when I find a new one of my interest. All this information get vectorized, and not vectorized once, each day. Each day I have a new information, I vectorize this information, and as soon as I get the new information, I initialize my financial summary agent. This agent send a newsletter. Each day I will see the newsletter soon, and get me all the information in my box on what is the summary and what will be my prediction on share over the next day. Then, if I not have enough information, I'm always able to click on a button and still query my Ragu chat in order to have more information, to deep dive on the data, to experiment more and get additional link of this information. And having said that, let me transition to my demo. And in a second. Oh. Okay, good. Good. You are now in the world of Ragu, so the project Ragu. Here, in this interface, you see that where I could upload my source of data. So first of doing, before of course I configured my LLM, I configured my vector database. This is easy menu here where I could configure everything. But let's give this for granted. And let's focus on the activity. So the first things I did is I load my company TK data and I create my financial custom source. That is, as you see, a Python code that could use whatever package you want. And in this case, is crawling the internet for searching technology information. This package is scheduled. So it's run 11 UTC, it means 7 a.m. US Eastern Time. So each morning at 7 a.m. I will get my newsletter. Then, of course, I could tweak a bit my retrieval settings in order to, I want the LLM behave a financial newsletter, so I suggest the prompts. I give some tweak on the prompt, and as you see, I give also query limit, and we have the ranker option that Erica explained very well. And all this setting is possible. So we set up how we want to interact with the LLM. And then we create a collection. A collection is our single point of contact with your data, the minimum securable object, and also the object we use in order to get together the data that are common. So if you have different topics, you might create different collection, and then you could query all collection together or separate. So we offer the possibility. But in this case, we have all this financial data. So we create a single collection. And this collection, we added our two sources. That is the 10K and the Dala Financial News. And this is our collection. And with this in our collection, what we did is also create multiple configuration, because the tool allows us to experiment, as I say before. So I could experiment along embedding model. This is what I did. But I could also experiment with compression. And also I could define some important setting on the strategy, how I could keep the document, because if the document change, I might want to decide to keep all the history, or I want to just have the last snapshot. This is all possible thanks to the configuration update strategy. Then there is a lot of more settings that we could deep dive if you want our boot, Streaming AI. But the important point I want to still show you today is that we could also work with all type of unstructured document, including images. We support OCR with Paddle OCR and Tesseract natively with multiple language. And we also support, that it's very important, this table extraction, as we say before, because tables are unique content and if we keep the structure of the table as they are, LLM is able to answer questions on our table and correlate them. So in this case, we store the tables, we recognize tables, and we store them in Markdown language in our database. Then, this is one configuration, but I could do multiple configuration in my things. I could have, in this case, I have BGE-based, that is a more bigger model. I have the small one that has less vector, and they have the compressed one. But okay, then I have multiple, this match of configuration, how I could decide which is the best one, how I could define my champions. The tool offers two opportunities. A user evaluation, so we could define our test cases. That is a subject matter expert, a person that understands our data is able to write down, or we could get from our user, from the wrong answer we get from the chat. And we could really create the question and some assertion. So we expect that LLM contains some result, or we put some advanced logic to check what is inside of the data. If this text is, then we could run this test, we write all these tests, we could run it against the different data set and check if all or some of them respect our constraint as a user. But in order to make this simpler and faster, we also allow auto-evaluation. Auto-evaluation is take a different approach, so we are able to generate the question using LLMs. So we are running LLM object that's use a language model, the one you choose, you could select one, and generate a test case that covers a portion of your data. So you could decide the amount of coverage of your data. And then you get automatically the question, and you could run the question again against your data set, and we provide you what we call Raga score. Raga score is an open source scoring engine that allows us to create a single number that represents the quality of your vector search. This, of course, we have all details as usual as SAS with all information, so you get all the answer for every question and also all the submetrics used to generate a single value in order to help you to tweak your data and improve them. It's important to bring together these two values. Auto-evaluation is very good to smoke the surface. User evaluation is very important to really go to the point of your question or your important answer. You want to be sure that the system is able to handle in a correct way. All these numbers come back in this interface, and you could choose your champion. Based, of course, on the Raga score, but you could also choose it based on the space they use on the vector. And you see that each of these models has consume a different space in the database, in the row size. Of course, the BGE base is the biggest one we know is better, but also has a higher space in the memory, in the database that results also in higher space in the memory, as we say with the memory indexing. And the GT small, the one we compress, has less value. So you see here the BGE base, and the other one, the BGE small, is really the smallest one, and reduced by a factor of 10 the space that we consume in the database. Having said that, we select our champion, and we could go to the next step of our journey, so to develop our financial agent. In this area, we could develop, import, and set up our agent. And first of all, of course, we define some settings. We define the code, and I want to highlight you that we could use SAS also in this code. This is Python code because we are able to import the SAS VIA library you see in the Workbench demonstration in the first day. And we offer all set of SAS Python library. In this case, we use logistic regression for a simple example, but you have the full-fledged data set. Then, of course, you could tell which LLM model is allowed to use the model. So you decide, and you could change it, of course, for cost reason or for security reason. You decide which collection of data is allowed to use, still thinking that it's not enough to select it here. Also, the user needs to have permission. If not, you will not be able anyhow to read the data. And then you could define some parameters in your model. So you could tweak it, and you could change it and reuse it in multiple scenarios. In this case, we check which tickers, which share we want to look to, and we say which email we want to send the email each day. having said that, we could go to automation. So all this is good, but we want to send the email each day, not once. So with the automation feature, we are able to check as soon as the document is updated, and the document could be updated manually. So if I do the manual update, I will trigger this automation for the company take case, but each day at 11, since the daily financial news run each day at 11, I run this script. And what it does, the script is able to generate a new vector, so it's update the vector store with the new data, and automatically generate this data, and is also able to, if we want, to reevaluate. So we have the possibility to reevaluate the data and maybe find another champion. At the end, it sends a notification to the agent. We have new data, so you could start again. The agent get the new data and provide the daily newsletter that I just received in my inbox now. And we have finally the Project Ragù Financial Times in my inbox with all the market performance we get in the last 30 days, the highlight of the most important news of the day, and with all the link to the data, and also the profit that will allow us to tell how it's going with our shares. And that's in this case, we know that Apple is going up, Microsoft is going down, but we could have a forecast on what will be the next day's shares, and so we could say, okay, what will be better to invest on. But it's not end over here. I could go back to my Ragù chat, and then I have a chance to chat with my agent. And let me enter a new chat, and here we get back my financial agent, and let me ask a question to this agent. So, why we know that NVIDIA stock increased, but we want to know why. Sorry. Okay. In the meantime, I'm asking this question, and this is elaborated. So let's see. So, and we get the answers suddenly. So we understood that the reason and the report. The reason is the report that the administration might release a bit the restriction on selling chips abroad and simplify the export. Is a huge benefit for NVIDIA. This is very interesting, but the most interesting part is not only I get this information, but I could know why I get this information, because I'm able to navigate back the data I stored with my previous source, and I really get the news. Get the link to the news, I could validate and verify what was the source of my information. And having said that, this will conclude my demo, and let's return back to the slide. Hopefully. Okay. And let's have a small recap.
All right, so in summary, I talked about Weaviate, I gave an overview about it, and then I covered the 3 search methods. So the retrieval in RAG and agentic RAG. So that was keyword search, vector search, and hybrid search. Then I covered the second stage retrieval, so re-ranking, and then how you can build agentic RAG solutions by using Weaviate and SAS together to take your vanilla RAG to fully autonomous and agentic applications that are able to reason, retrieve, and act across your data.
Yeah, and thanks you, Erica. And as I promised, we are building this application you show is a brand new application you're the first to see. We are building a SaaS, and we aim to launch it in Q3 2025. So thank you very much to join us today. We have an additional demo on RAG, and the streaming AI corner is just around there. It's a very interesting demo because this demo is on industrial fan. So, and how we could not only predict the fault, but also suggest the best solution for our fault. And time for your question.
Oh, wow.
Thank you. I don't think we can hear you. Oh, yeah. Try again. It's working now.
Okay.
Okay, now I hear you.
Thank you for a great presentation, guys. In terms of the financial ragu, how much backtesting did you guys do to see? Sorry, how much backtesting did you guys do to see how accurate it is? And if so, what was your accuracy?
I mean, we, as you saw, we provided the test, and I mean, the accuracy was quite impressive. I mean, you say 80% of accuracy, it was the result of our test. So, I mean, it's pretty accurate on the data we provide, and was quite satisfied. Then, these are the question made, especially the automated one, is pretty complex. So, is 80% is good value. I mean, it's not mean that it's failed 20%. It's meaning that even with complex question, it's still able to resonate. So we find it pretty correct, and we also all the time able to see what's data. So if we have something not correct, we could flag the thumbs down, and this will trigger additional tests. But so far, we are happy with this solution.
Can I clarify one thing in my question?
Sure.
So with regard, I don't know what you're referring to in terms of the accuracy part. Are you referring to the sources going back, or are you actually referring to the prediction prices? Like,
Okay, no, I mean, I'm referring to the retrieval part, so the
There you
return
go.
or RAG. This
Yeah.
is what we evaluate. The prediction part uses standard SAS tools,
Right.
and was an example, just an example how you could use SAS code
Right.
in things. It was not meant to be precise, not meant to really suggest you to
Right,
purchase things. It was
Yeah,
just
yeah.
meant to say you could do standard analytics together with LLM. So this is the purpose of these
Right,
things.
right. All right. Thanks for the clarification.
Yeah.
Great job, guys.
Thank you, thank you.
Thank you so much. Are there any more questions? I'm going to bring it right on over. If not, give it up for Erica and Daniele one more time. Amazing presentation. Thank you so much. We're super excited to have you. We'll be back in about 15 minutes with another breakout session.